Welcome back, everybody. Hope you had a good break. Got to talk to a lot more people here. Got to learn about who's here exploring with you. And we are here for the last segment of Pragma New Delhi. 3 more talks to go, and we're going to launch into our happy hour. So without further ado, let's get started. Our next speaker is Preetam, and he's going to tell you all about making adversarial AI to make crypto contracts safe. So please give Preetam from QuillAudits a big round of applause.
Hey, hi. Hello, everyone. So, we started our journey back in 2017-18 as a blockchain developer, and then we moved into blockchain security. So we into security stuff from last 7-8 years. And about me, we work with around 1,500 plus protocols. 1,500 plus protocols we work with. This is a big, big number. But out of 1,500 plus protocols, if I have to see in last 7-8 years, you can say 90% already died, right? Someone was just to make money, or someone was maybe just to raise money, right? So that, they can show to their investors, they can do marketing and everything. But there is one thing that is always, always constant. Like out of those, 1,500 plus projects we audited, and there is so many other, protocols in the space is also there. There is one thing that is always, always constant, and that constant is every week is number of hacks and scams that are going in the industry, right? Because the space is so new, right? And this is very good money is there to make, and as a founder or as a Web3 security founder, if we're working with any project, we seen so many times, maybe this project is doing good, and maybe they're running the protocol for 1-2 years, and you see in 1-2 year they are doing some rug pull, or they are just exiting the project, right? So security, in the security space, or you can say in the Web3 space, trust is so much minimal, right? I can't trust my developer also. I can't trust the development company I'm working with. I can't trust my founder also. We've seen so many cases, your founder is doing the hack, your developer is doing the hack, or your third party company is also doing the hack, right? And we have seen like $150 billion is currently TVL, and but only this year around $3 billion already gone into hacks and scam, right? And and nowadays the attack vector is not just token contract. Like back in day when I started my journey in Web3 in 2017, the scope was just a token contract. Let's get it audited and let's make money, or maybe let's do the ICO, or let's do the token launch, right? But nowadays, the space, or you can say the attack vectors are completely different. We have cross-chain stuff. We have so much, modular stuffs are there, right? So attack vector is so much there, and there is so much cross-chain vulnerabilities is there. There is not a single ERC20 token. We have now lending, AMM, flash loans. There is so much things are going on. And as a there was a one talk, I think 1-2 hours back, around how we can AI into security space, right? And that is a good, right? How as a developer I can use AI, any AI tool, for just pre-scanning any smart contracts, so that I can find some initial vulnerabilities. But I still feel the tools are very much minimal, right? If we see static analyzers, they can find some, you can say, predefined vulnerabilities like re-entrancy or anything. If we see symbolic analyzers, they can go to any path and find some vulnerabilities, right? But they can't go to every path of the smart contract. Path means the state of the smart contract share. And then we have fuzzing, right? Fuzzing is, nowadays everyone is talking about how we can use fuzzing to find the vulnerabilities in the smart contracts, right? But fuzzing is having their own issues. Fuzzing is like, you just throwing the dart to find, if that dart can hit the, goal or anything, right? But this is kind of a noise. It's not 100% foolproof. You can use fuzzing to find 100% vulnerabilities. So how we can do it is the main thing. And now the space is more interesting now, right? Agents are everywhere, and what I feel as a Web3 guy, I was just listening to podcast of one of the good founder, Web2 security company, Palo Alto Network. how the hacker or even as a normal user, I can use any LLM to say, hey, go to this website, find the vulnerabilities, how I can hack this website, right? So now this ChatGPT is kind of, kind of dangerous weapon for you guys to find any vulnerabilities, or maybe you can use these AI tools, right? Like there is some AI audit tools are there. As a hacker, you can use AI tool. Like who's stopping you really not using this AI tool to find the vulnerabilities in smart contract and to make money, right? It's just you do the login and you do the payment and you're able to find any vulnerability. That contract just got deployed. You can really make the money, right? So I feel this is something very very new, and it's going to be more dangerous, right? And if now we see the case of AI agents, I'm only going to talk about now AI agents. In case of AI agents, like we have multiple frameworks like Virtuals, Elijah, and there is more frameworks around Web3 also. In case of these frameworks, we have seen some cases where the hacker was able to manipulate the agent, and he can just give a prompt, hey, forgot everything about my last transactions, or maybe what's in your memory, right? In any agent, the main thing is the memory, right? What the agent is currently in his context. You can give a prompt, hey, forgot everything and do this stuff, right? And the hacker was able to manipulate that agent in, I think, 40 plus attempts, 40 plus attempts, not a single attempt, right? And in 40 plus attempt, the agent was like, okay, I will do the transfer from my wallet, that is my custody, and that agent was able to transfer, right? So now these LLM-powered agents are, again, kind of non-deterministic, right? Smart contracts are deterministic. Deterministic means you know the state of the smart contract. You know state of every smart contract, what can be the end result. But in the LLM, you don't know the state of any AI agent. The input can be same, and the outcome can be always different, right? So in this like non-deterministic cases, the hacks, or you can say how we can build guardrails around AI agents is more difficult as compared to the smart contracts, right? And nowadays, like everyone is building AI agents, like in you can say maybe on the base, like let's get on chain, or maybe on any chain. Every chain is focusing around how we can build the AI agents. And if everyone is building the AI agents and the traffic is going to, traffic means like you are creating the smart contracts, anything using AI agents, it means there is more vulnerabilities in your smart contracts, right? So, and we have seen the one case of Elijah. Like as I mentioned, the hacker was able to manipulate the Elijah via bad prompt and able to hack around I think 100K dollar. Okay, so now the case is here. As a security person, being into security, work with so many protocols. We have one AI audit agent also, and I feel that agent is okay, right? And I have tested all the AI audit agents, and I feel they're good, they're okay. They are finding the vulnerabilities that you trained on. They're finding the vulnerabilities that is already in your database, or already your agent is trained on, right? And we have seen the cases of even the monitoring companies where you saying, hey, we could have stopped this hack $40 million if these guys used us, right? But maybe the company is not using, or maybe the company is just doing the tweet for their marketing, right? But we, like in last 2 years, like there is very rare case where any AI audit agent or monitoring company said, we stopped this $100 million hack. There is not a single company. But there is so many tweets say, if you guys used us, we could have stopped this $50 million hack or scam, right? Because you can say your tool is maybe algo based, or your AI agents is just trained on the past vulnerabilities, but how you can find the new zero-day vulnerabilities is the game, right? And that's going to be more interesting. So how we can do it? Like, so there is, in the AI thing, there is three things. One is how you train your model, right? It can be via supervised learning, it can be reinforcement learning with human feedbacks, and the third is self-learning, right? Self-learning is the most important, that is going to play the role. It can be for smart contracts, or it can be for AI agent security, right? Self-learning means how your agent works like a attacker, and he learns himself, and he can find the new vulnerabilities, and and he can report you before a real attacker is doing it, right? So that's how you can build an adversary, and this agent can report you before any hack is going to happen. Okay, so I'm going to show how we can do it. Um, okay, so as I mentioned in the smart contracts, there is 3 ways, like one is static analyzer, one is symbolic, and one is the fuzzing. As I already mentioned, they're good. They're good if you are a developer, you're writing your smart contracts, use them, find good vulnerabilities, maybe 70, 80% vulnerabilities, and go to the manual audit company. There is so good auditing companies is also there. As a QuillAudits company, we also do the audit, but now the main thing is how we use adversarial AI agents. Adversarial AI agent is more like offensive security. You are building your own attacker on your own smart contracts or on your system. That's the main thing. And these RL-based adversaries can figure out different state of the smart contract or different state of the AI agents, and can figure out how they can build the attack vectors, and they can self-learn. That's the main important, how these AI agents can self-learn, right? As we see in case of, I forgot the name of this LLM company from China, DeepSeek, right? They able to, win the game for some time, from ChatGPT, because they use RL for, learning or self-learning. Okay, so how we can build a self-learning framework for maybe for smart contract or for maybe for any AI agent? So there is a framework, we call it MDP, right? So there is 3 different important things. One is states, the second is the action, and the third is the rewards, right? State is what is the state of your smart contract. It can be a price of a token, it can be Oracle price, it can be any AI agent memory, it can be AI agent prompt. And the second is what kind of actions you're looking. Actions can be do this like 2, 3 transactions, transfer amount to this address to this address, try to do this re-entrancy attack or something. And the last thing is the rewards. If you're able to do it, you are going to get +1 reward. If you're not able to do it, you will get a -1 reward, right? So using this framework, we can use it for smart contract also and for any AI agents also. Okay. So as I mentioned, there is one important thing is invariant. So in this framework, we use the invariant. Invariant, you can say it's kind of a win. If you're able to break this invariant, you are going to win the game, right? So you can define an invariant, hey, if you able to, maybe play with the price of any oracle, and then you're able to inflate the price of any LP pool, it can be one invariant, right? And if your agent here means the adversarial AI agent, able to do it, it means it win the game, and then he's getting the reward for it. And if he's not getting, again, it is going to self-learn. That's the main important here. So as a Web3 security company, what we did we built a red team Copilot to test this framework. Like, can we really figure out build a framework to test in the smart contracts? So we build here like one adversary, and then, as I mentioned, you have 3 different things. One is state, reward, and transaction, right? So if you guys were there in the previous talk of Sasank from the Cred Shield, he given one example of one hack, right? Where the attacker was able to do some transactions, and then one transaction was around access control, right? So that transaction can be around access control transaction, right? And if there any you able to get to that stage, the stage can be you able to make yourself owner of the smart contract, then you are going to get the reward, right? So this is a kind of a red team Copilot. We build it, and we able to find so we trained that RL agent on re-entrancy vulnerability, and then he able to self-learn and find a new vulnerabilities, the timestamp vulnerability automatically. And we know, like, not given any training or memory or any context, but he able to self-learn and find a new vulnerability, right? So that was the main outcome. We were looking how we can use this RL-based adversary into a smart contract, and we tested into AI agents also. So we build a new product, QuillGuard, like how we can use this guardrail into the into the AI agents also. That's all from my side. Again, this thing that we're building is at a very initial stage, but this is a very good research paper we publish. And so I would suggest you guys to scan it, go to the research paper, how we doing it. There is some interesting math in the paper. But it is a again, I'm saying it's a very initial stage, but this space is going to be very interesting, how your agent can self-learn to do anything. It can be applied into healthcare, it can be applied into smart contracts, it can be applied into AI agents. So how you can build adversaries. Adversaries means a attacker to do any bad thing so the real attacker is not doing, right? So that's our goal here, and we able to build it. Thank you. Thanks, guys.